Hello friends, today I'm going to explain you about one of the several valves used in the hydraulic circuit. The name of the valve is the regenerative type of neutral direction control valve. This is the 4x3 valve which has 4 ports and 3 different positions. The application of this valve in those hydraulic circuits wherever 2 different speeds are required from a single system. As in case of a drilling machine, the drill spindle has to travel at a faster rate from its top position to the top surface of the workpiece, which is held at the base of the drill. So the drill will travel faster from in the first phase, and while drilling in the surface, the drill spindle has to travel at very less speed. So in drilling machine, two dual speeds are required. So there, this kind of regenerative neutral type of direction control valve can be used. So first let's understand the circuit made in the automation studio. This thing is the fixed displacement type of pump, which will pump the fluid in the whole system. Now this is the motor which will run the fixed displacement pump. The black lines shown in the whole system are the flow lines, which are the ducts or which are the pipes from which the hydraulic fluid is passing. This is a pressure relief valve, which will actuate above the cracking pressure. So when the pressure of the system reaches above the cracking pressure of this PRV, then the fluid will be diverted from the system to this PRV and to the reservoir. This is the pressure gauge which will measure the pressure in the system. This is the reservoir which will store the whole fluid which is used in the system. This is a check valve which will permit the flow in one direction and blocks the flow in another direction. This is a flow meter which will measure the flow in the system. This thing is a double acting cylinder. There are two different positions. This is the innermost position, this is the outermost position. As it is double acting, we can provide fluid in from both the directions, from the blanket side and the rod end side. And this is a piston. As in our case, it is the drill spindle. And this thing is the heart of the whole system. It is the regenerative type of neutral valve. Now, as I earlier said, this is a 4x3 direction control valve. So there are 4 different ports and 3 different positions. As likely, 4 ports are 1, 2, 3 and 4. And 4 different positions are 1, 2 and 3. A regenerative term is used to describe a system in which the waste is fed back into the system to supplement the input power. In this neutral, the pressure port is connected to both the outlets and the tank port is blocked. When this valve is shifted to the neutral, the pump pressure is applied to both sides of the piston. Because the piston area in the rod side of the cylinder is smaller than that of the blind side, there is net force applied to extend the piston rod. As the piston rod extends, it forces the outlet flow from the rod side back into the valve, where it combines with the pump flow and goes to the blind side of the cylinder. This causes considerable increase in the cylinder speed. This is the purpose of the regenerative neutral, that instead of sending the return flow back to the tank, it sends the return flow into the inlet side of the cylinder and thereby increasing the speed of the cylinder or the piston. Now we will see the actual working or the simulation of this system. As we can see, right now the piston is fully extended, so no more fluid flow can take place in the system. That's why the fluid is diverted from the system to the PRV to the reservoir. The red lines are showing the high pressure and the blue lines are showing the low pressure. The dotted line are showing the actual flow of the fluid. As we can see, the Cracking pressure of the PRV is 80.28 bar because at this pressure the fluid is diverted from the system to this particular reservoir. Also, right now the flow is 0 liter per minute. Now, as we actuate the third position, the piston will retract towards the inner dead position, and the flow and the pressure will change constantly during the process, as you can see. The blue lines are again the low pressure line and red lines are high pressure line. Right now the pressure is low throughout the system, and the pressure and the flow and the pressure are constant right now because the flow is uniform. But as the piston will reach the inner dead center and the outer dead center, there will be an abrupt change in the pressure and the flow. Now, as we actuate the first position, the same procedure will take place, but the cylinder will extend. Again, the flow line are shown with blue color, so the flow pressure is less, and the pressure and flow we can see here are very less. Now, as we actuate the second or the neutral position, as explained earlier, both the flow from the pump and the remaining fluid from the rodent side will combine and will directed to the blind side of the system. So the speed will increase considerably, and the increment of the speed will be seen in this simulation. As you can see, the speed is increased. Also, there is huge change in the flow and the pressure occurring in the system. As in the case of retraction, the flow is 64.24 liter per minute and the pressure was around 5 bar. But in the case of extension, the flow was around 52 liters and the pressure was around 2.3 bar. But as explained earlier, the flow here, as we can justify, is almost very much high than the extension and the retraction, which is 191.64 liter per minute. Also, the pressure at which the system is working is quite high, which is almost is 8 times higher than the retraction pressure. Now, if we consider this piston as the drill spindle, so it must travel faster at first and then travel slower according to the need. So what we can do is we can actuate the second position or the neutral position first up to some extent, and then we can actuate the first position, which will extend the piston also, but it will extend the piston as quite low speed, as we can see. The system the system is extending at high speed right now, and it will extend at lower speed. The pressure will be higher in the case of high speed, and the pressure will be lower when the speed is lower too.